Okay, question is what is the temperature of steel copper junction in steady state? Again, they are in steady state means rate of heat transfer will be same, okay, through both steel and copper junction, copper system. Now this, they are connected in series. So all, now from here these are all about the informations, okay. So let's suppose this is steel, and length of the steel rod is greater than the length of the copper rod. So let me take this one as steel and this one as copper. So this is 15 centimeter steel, and this is 10 centimeter which is of copper, okay. Now what is happening, the temperature of the furnace is this much, means where from the heat is coming, that is 300. So let me take this one is 300 degrees centigrade, and the temperature at the other end is 0 degree centigrade. So see here, no need to see that in which side you are taking 300 degree centigrade, okay, because at steady state condition we have to equate all these two terms, okay. So no need to take that furnace, why are you taking, sir, in steel side, why are you not taking in copper side? You can take, no problem. Now here their cross sectional areas, I think same area of cross section, no, the condition is given, the area of cross section of steel rod is twice that of the copper rod. So basically area of steel is twice to that of copper, ACU. Area of steel is equals to 2 ACU. This condition is given. Now since these two are at steady state, the whole system is at steady state. So if let's suppose the junction temperature is T, this one is the junction temperature. So temperature difference for the steel wire or steel cube will be this 300 minus T, because highest minus lowest. So K steel into A steel into 300 minus T, temperature difference, divided by length of the steel wire. Length of the steel is how much? 15. I am not changing the units. Why? Because if at the left hand side it is 15 centimeter, at the right hand side it is also 10 centimeter, so both are in centimeter unit, they will cancel out. So this is why I am not changing. Now in for copper, see K copper, A copper into, for copper it is T minus 0, right? T minus 0 divided by how much? Divided by 10. Now Ks is known, Ks and all these things are known. For steel it is 50.2, so 50.2 into area of steel is 2 into ACU, so just put here 2 ACU into 300 minus T by 15 is equals to KCU is how much? That is 385 into ACU into T by 10. Now after cancelling and all the means like ACU will cancel here, after cutting it in by 3 by 2, you can easily solve the whole thing, right? The equation can be solved and T can be measured, right? Easily T can be measured, can be calculated. So let me finish the thing. Like if you cross multiply, what you will get, this 2 will come here this side. So 4 into 50.2 into 300 minus T, and here one 3 is at the denominator, so if you multiply at that side, so 385 into 3 into T. So this is the main concept, this is the main line, okay, from which you can easily find out T. I am not going to the calculation, because it will be very complicated and lengthy. Not complicated, actually lengthy. Okay, so after solving this you will get it value of temperature. So the process is like this, okay, means at steady state condition the rate of heat transfer through steel and through copper both are same. This is the main concept, and now use the after taking the junction temperature as T, you can further proceed with the calculations. Okay, I hope you have no doubt. Thank you for watching. Thank you.